In this lesson, we are going to start on section 2.1 in your book on page 161. The title of this section is Formulas and Problem Solving. For our specific lesson, we are strictly going to be working with the formulas. The directions say to solve each formula for the indicated variable. So what we're going to be doing is looking at a formula that is used in real world life, and we are going to solve for a specific variable that the book asks us to solve for. So I always give my students steps to solving equations. Those steps are generally to remove the parentheses first, then to combine their like terms on each side of the equal sign, then to move all your x's to one side, so you would move the smaller x, and then to solve as normal. But that's not necessarily going to help us out here on these problems because all we have are letters and maybe a few numbers. So it's not solely just trying to find a single number for a variable. So for that reason, I'm going to give you guys some different steps to help you out with solving. So steps for solving in a formula. So step one is going to be to remove the fractions. And by that, the denominators are the big issues that we want to get rid of. And then step two is going to be to do the opposite that is being done to the variable. Okay, so make sure that you remember that our order of operations is please excuse my dear Aunt Sally, and that generally we start with the parentheses and go all the way down to the subtraction. However, since when you solve, you're always doing the opposite that's being done to your variable, we're actually going to do the opposite of these four bottom operations. So we're always going to take care of the addition and subtraction first, if that is in our problem, and then we'll work on the multiplication and division. So now let's go ahead and look at problem number 2 on page 161 in your book. Number 2, the formula is V equals BH, and we're solving for B. Okay, so it may help you guys if I highlight what we're trying to get by itself. So that's what we want to get by itself. That's our entire goal. So if you look, the H is the part of the problem that is keeping the B from being by itself. So what are these two variables doing to each other? Well, when you have a B right next to an H, that means that they are being multiplied. So the opposite of multiplying would be to divide. So you are only dividing by what you want to move. Okay, so if I wanted the B to move but I wanted to keep the H, I would have divided by B. Okay, so these H's will cancel because whenever you divide anything by its exact self, well, then that's going to give you 1. And so that leaves us with our answer of V over H equals B. That's all they're asking us to do there. Okay? So now let's look at problem number 4. For number 4, we have I equals PRT, and we're solving for R. So just in case this highlighting stuff is helping you guys out, I'm going to keep doing it. So the R is what I want to get by itself. So the things that are in the way are the P and the T. And if you look, since all of them are right next to each other, nothing in between, no signs, then that means that they're all being multiplied. So in order to get that R by itself, we're going to divide by a P and a T. It's okay to do more than one of these variables at a time. So those P's and those T's are gone, and that leaves me with I over PT equals r. Okay, so now let's go ahead and look at problem number 6. Excuse me. So on number 6, we have v equals pi r squared h, and they want us to solve for h. So look at what's being done to that h. You've got an r squared and a pi right next to the h. That's what's keeping it from being by itself. And what we mean by itself is that it's the only thing on that side of the equal sign. So all of these next to each other means that you are multiplying them. So the opposite of multiplying would be to divide by pi r squared. Oops. Okay. So the pi's would cancel, the r squares would cancel. So that leaves me with v over pi r squared equals h. Moving on to problem number 8, we have p equals I squared r. And they want us to solve for r. So look and see what's being done to that r. I've got an I squared next to it, and that means they are being multiplied. So the opposite of multiplying would be to divide by that I squared. So my I squareds are going to cancel, and I end up with p over I squared equals r. All right, now number 10. All right, so we have y equals mx plus b, and we're solving for m. So this one's actually going to be a little bit different than all the other problems that we've done so far, because this is the first problem we've looked at where there is addition or subtraction right there on the same side that we're trying to solve the variable for. So I have a plus b. Remember in the steps that we wrote down a few minutes ago is that the first thing you need to do is remove the fractions, which in this problem there are no fractions. And then we do the opposite that's being done to the variable, but it says that we're supposed to do our addition and subtraction first and then move to the multiplication and division. So we are adding b to the term where the x is. So the opposite of adding b would be to subtract b. When you do that, you'll get y minus b equals mx. Okay? And then, I'll highlight it again for us because we're trying to get that m by itself. In order to do that, we would divide by x because these two next to each other mean multiplication, so the opposite of multiplying would be to divide. So we would get y minus b over x equals m. And I know I kind of tell you guys that you always want to put these in alphabetical order, so like the negative b should come before the y. But to be honest, all we're trying to do at the moment is seeing if you can get that one variable by itself, so we're not going to be too picky about the alphabetical order. I don't want y'all to make any mistakes by not keeping the b negative. All right, so now let's look at problem number 12. All right, so number 12, we have k equals 1/2 mv squared, and they want us to solve for m. So the first step is to clear your problem of fractions. Okay, so in order to do that, well, if we have a 2 in our denominator, I taught you guys in a previous class that you should multiply, sorry about that, that you should multiply by that number in your denominator. So if I were to multiply by 2 here, let's do this math on the side. If you have 1/2 times 2 over 1, well, that gives you 2 over 2, which is just 1. So by multiplying by 2, that's how I get rid of that fraction. So that's gone, and it leaves me with 2k equals mv squared. And so now the m isn't quite by itself yet, so now we need to divide by that v squared because you are multiplying. When you multiply, you do the opposite, which is to divide. So now we have, for our answer, we have 2k over v squared equals m. All right, so now let's move on to problem number 14. On number 14, we have 2x plus 3y equals 6, and we're solving for x. So we've got some addition and subtraction on this side, so we need to take care of that part first. So we need to get rid of this plus 3y. Well, the opposite of a plus 3y would be a minus 3y. So that gives me 2x equals negative 3y plus 6. Okay? So, got my x that I'm trying to get by itself. So now I am going to divide by 2 because this means that you are multiplying the 2 by the x, so you do the opposite, which is to divide. So I would actually accept two answers here. I would either accept the x equals negative 3y plus 6 all over 2, or I would accept x equals negative 3y over 2 plus 3. And the reason is because if I divide negative 3y by 2, well, that doesn't simplify. But if I divide 6 by 2, that gives me 3. So this is just a more simplified answer, but I would have accepted either one. Now let's look at 16. AX plus BY equals C. And we're solving for Y. So we need to get that Y by itself. And notice that we have addition here. Okay, we are adding the AX to the BY. So the opposite of having this positive AX would be to have a negative AX. That's how we're going to get them to cancel out, to move. So that gives me BY equals negative AX plus C. If you wrote C minus AX, I would still accept it. That's fine. And then we're getting that Y by itself, so the B being next to it means that you would just have to divide by B. So Y equals negative AX plus C over B. Okay, number 18. On number 18, we have V equals 1/3 pi r squared h, and we're solving for h. Well, the first thing you should think to get rid of is that fraction there. And remember, the way to get rid of that fraction would be to multiply by what's in the denominator. So we would multiply it by a 3. And what you do to one side, you've got to do to the other. So that makes these two 3's cancel, and I get 3v equals pi r squared h. So remember, we're solving for h, and having this pi r squared next to the h means they're all being multiplied. So we're going to do the opposite, and we're going to divide by those. So those cancel, leaving us with 3v over pi r squared equals h. All right. So now let's look at problem number 20. On number 20, we have d equals c minus s over n, and we're solving for s. So this one's going to be one of the trickier ones that we've seen so far. So we're trying to get this s by itself. Well, the first thing you should do is get rid of the denominator. Okay? Anytime you see a denominator in here, we want to get rid of it. So we'll do that by multiplying everything by n. Okay? So that gives us dn equals c minus s, because these n's are going to cancel. So we're getting that s by itself. So this is c minus s. So they're not being multiplied because they've got that subtraction sign in between. So we want to move that c by doing the opposite. So if this is a positive c, we're going to do a negative c on both sides to get this one to cancel out. So we get dn minus c equals negative s. Okay? So now what we're going to do is we're going to have to get that s by itself, because we don't want to have a negative s. We want to have a positive s. So we do that by dividing by a -1. Because if you think about it, the number understood to be in front of a variable is a 1. So imagine that that says -1s. And so that means that you're multiplying by a -1. So the opposite of multiplying would be to divide. So when I divide each of these by a -1, that gives me negative dn plus c equals s. And if you had put c minus dn equals s, this is the same thing. You're just switching these two terms around, so I would have accepted that one as well, as long as the dn was the negative and the c was the positive. So now number 22, a equals p plus prt, and we're solving for t. So we need to get rid of this addition first. So this is a positive p, so the opposite of having that positive p would be to have a negative p. So we get a minus p equals prt. So to get that t by itself, you do the opposite. So the pr next to the t would mean multiplying, so we're going to actually divide. What you do to one side, you do to the other. So those are going to cancel, leaving you with a minus p over pr equals t. All right, so now let's move on to the last problem of this section. And this one is going to be a lot of fun because this one is very fancy. So if I have a equals 1/2 h times b plus b. So that's a big B plus a little b. And we're solving for that little b. All right. First thing you should do is take care of the fraction. So you multiply both sides by 2. So you get 2a equals h, and in parentheses, b plus b. Okay, so now I know that we say that you're supposed to take care of the addition and subtraction first, and then the multiplication and division. However, notice that this addition is inside of a set of parentheses. So we need to get rid of this h first, only because it is keeping us from adding or subtracting anything on this side. So we're actually going to have to divide both sides by h first. So you get 2a over h equals big B plus little b. Okay. And now you would subtract the big B from both sides, because that's what's keeping us from getting that b by itself, the little one. So we get 2a over h minus b equals that little b. So I hope that this video has helped you, and I wish you the best of luck.